Hey guys, welcome to the channel. We're going to be solving question 43 from the 6th chapter of the Beer and Johnston textbook. I'm going to find the force in the members CD and DF of the truss shown, and since we are going for specific members in here, we can use the method of sections as opposed to method of joints that we go to each joint in order to find the force in the member. And at the end, we're going to state if the member is in tension or compression. But before we start, we have to figure out the forces at these two supports that we have at point B and J. We have a pin at point B, which means we have both X and Y component. We can call it Bx, By. And if you look at J, we'll see that we have a roller. And since we don't have any friction in X direction, we don't consider any force in X. So the only force that we have in here is the force in Y direction. We can call our X and Y in here yx. And now is the time to use our equilibrium equations in order to find the unknowns in here. So we have sum of all forces equals 0, and we have the same for moment. So if we do the sum of all forces in x direction, we'll see that the only force in x direction is bx, which means this force is 0. So we only have y components for b. So since the truss in here is not symmetrical, we cannot go with Fy because our By and J are different. So we can go with the sum of all forces in one of these joints, maybe J or B, doesn't really matter. We can go with J, we're going to call it counterclockwise positive as always. So if we look at it, we'll see that we have the moment of the first 12 kilonewton here, which the moment about J is counterclockwise, so positive 12 times the vertical distance to the line of action. So this distance, and from the question we know each panel is 2.4. So positive 12 times 2.4 plus the other 12 kilonewton force. Again, this one makes counterclockwise moment. So 12, and the distance this time would be from F to J. So we will have 2 of 2.4, which will be 4.8. And at the end, we have the moment of By, which is going to make a clockwise moment. So negative By times the distance would be from B to J. So 4 times 2.4, which will be 9.6, is equal to 0. So from here, we can find the By. So 9.6 By is equal to, if we factor 12 in here, we have 4.8 plus 2.4. And here we can find By. 12 times 7.2 divided by 9.6. That's going to give us 9 kilonewton. No negative sign, that shows that By is in the correct direction. Now we can do the sum of all forces in the Y direction in order to find the J. So we have By, which is 9, plus J minus 12 is equal to 0. So here J would be 24 minus 9, which will be 15 kilonewton. All right, now we have all the unknowns that we had at the first place. Now it's the time to do our section. So the way we're going to section the truss is to section those members that we are trying to find. So we have CD and DF. So our section has to cross these two members. So we have FD here. This is going to cross CD2, and if we continue our section, we'll end up with something like this. We're gonna go with the free body diagram of the left section because it's much easier. We have less forces in there. So what we're gonna have is just gonna draw the free body diagram of that member. So we have the point A, B, D, and if we continue this here, we have our C. We have this force at B, which we found is 9 kilonewton. So we have these members that are attached to here. Since the 9 kilonewtons upward, the only y component that we have is this force, which is FCD. This has to be downward in order to cancel out the 9 kilonewton. And regarding the direction of the other two, we can just pick one direction for now and we'll figure it out later. So what we can do in here is that we can just consider these directions for now, and if we get a negative sign later, we're gonna figure out the direction. So this will be FDF. So again, we are looking at this, which these are the members that we have to figure out. Actually, this is down. So now it's the time to do the sum of all forces in X and Y. If we do sum of all forces in Y direction, we can find FCD. So 9 minus FCD is equal to 0. That shows that FCD is also 9 kilonewton. We found the first unknown that we needed to figure out. So this will be the member in here. And based on Newton's law, the member has to be in the opposite direction. So this will be in compression. So we found FCD, and in order to find FDF, the easiest way in here is just to go with the moment about point C, because that way we can cancel out all the unknowns and we only end up with FDF and 9. So we can figure out the FDF pretty fast. So if you look at it, we see that FDF is going to make a counterclockwise moment. So it's positive FDF times distance, which will be the side of this truss. And if we look back in here, we'll see that this is 1.8. So here is 1.8 meters. So 1.8 minus the moment of the 9 kilonewtons, since it's going to make a clockwise moment. So 9 times, we have one of these panels that we know that each of them is 2.4. So this distance is 2.4 meter. 9 times 2.4 is equal to 0. And basically our FDF in here would be 9 times 2.4 divided by 1.8. And this is going to be 12 kilonewton. And we just have to figure out if the member is in tension or compression. So we didn't get any negative sign. That shows that this was the correct direction after all. And we have to have a force in the opposite of this one, so the member will be in tension. And that would be the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. Feel free to check out the playlist. We are covering three different textbooks in this channel for engineering mechanics. Let me know if you have any specific problem that you want me to cover in the next videos. And you guys take care. I'll see you in the next one.